Hi, my name is Mohammed and I work with Dr. Jeff Smith here at Auburn University, and I'm just gonna do an overview of the manufacturing line and manufacturing plant simulation model so that it would be easier for everyone to understand what's actually happening in the system. So as you can see in the screen here, the model as the layout shows, we have two rooms. I call this room 1, the big one, and this one room 2 in the rest of the video. So if we just let things play out, I'm just going to run and set a speed of 5. Well, that's good. And as you see, I put the ending as 480 hours, which is 20 days. It's not an experiment, so it's just a runtime. So if we just play, as you can see, here are the cabinets that we keep the raw material, PCB, sensors, and base plate. So this is the base plate. After bringing all the base plates, they started bringing sensors, and now after that, it's time to make it. It's time to just run the gantry. As you can see, we have 6 modules here. Let me just pause it here for a second. So when the simulation started, as you saw, and you'll see again, when it actually they brought 6 base plates and 3 base sensor plates of 2 sensors. Up front, they created a batch of 6 here. It will be sent to the gantry, and then one will be hand the gantry. The other worker will start making the glue. After making the glue and attaching it, so this worker is now working on the gantry again. This worker is free. It will go on and bring the next batch of the sensors. This next batch of the base plate and sensors. So if I just run it again, you can see that it's bringing up the sensors here. This is the base plate, sorry. Base plates are coming one by one, as you can see, and after bringing 2, they create a plate of 2. But sensors are bringing in the batch in a plate of 2 together. So now 6 is ready here, so a new gantry plate is ready, but the gantry is busy here. After the gantry is done, which it takes about like 30 minutes. Should be any minute. So yeah, you can see that, well, this one goes to the gantry. This worker will start creating, making glue, and the next worker here will actually start working on this. So this model, we have 3 batches instead of 2. So just to show the capacity of the system, you can just change it, and I will show you how. But well, again, another batch of 6 will coming. 6 base plate, 6 sensors. Then this one ends, which takes about like 30 minutes. 30 minutes in simulation time, as you can see here. So it should be like any minute now. Yep. So again, a request for making glue, a request for going to the gantry and handing it. So yeah, the first day, 6 here, 18 proto modules will be created. As you can see, after these are created, they will go to here. So let me just go to the when they're done, I'm just going to go to the 3D model of the system. So I try to make this model as close based on some of the 3D models that you sent me, and some that based on the layout, I found most closest to the actual shape. So as you can see, this is the gantry. The worker is here. So if we just rotate this here, you can see that after these are all created, they will go to this cabinet, to this closet here or whatever, and they will wait for the next day. This is the curing phase, which is happening. So this will take another few minutes. Well, it's done. Now both workers are idle. They don't have anything else to do. They created 18 proto modules, but because this is the first day, they don't have any proto modules left from the day before. So The time. So this is what happening. The rest of these as they were in the model here. So these here, they don't actually do anything. So we'll just say just kind of like a cosmetics. So we're going to go to the next day. So I'm just gonna do it in a step, and a step will jump to the next event that will happen in the system, and I increase the speed to like really fast, which is the next event that happens in the system is 8 a.m. tomorrow. So we run it all the way to with 3000 with the speed of 3000. Well, it's now 8 a.m. of August 25th. It started at August 24th. So we decrease the speed to 5 again. So now what we need to consider is that we have 18 new modules coming in. Sorry, I just wanted to let them, then does not show the links and nodes to make it more well clean and clear. So yeah. So the next day we have 18 new 3 batches of 6 of new products coming in, and we also have 18 in the system right now. So as you can see, this is the number entered into the queuing. We see that there's 9. So the numbers that entered in the queuing are in batches of 2, in the plates of 2. So 9 plates of 2, 18 entered to the system. So, and then if we just let's start playing. So yeah, so then the 18 the next day are out, and they're waiting to be sent to the OGP, and we'll check for the quality. The first thing the workers do, will start with the new batch here. They will bring up the new products all the way here, as you can see. And as you can see, when they are moving sensors, they move way slower, because well, the sensors are, well, they're more sensitive. Then worker will pick something from the queuing, sends it to the OGP, and start working on the OGP. So as you can see, there are 2 products in the OGP right now, and they are in the OGP. One of them is waiting, one of them is processing, and this is the output line. So there is one of them is waiting to be processed, one of them is actually in the machine. So as you can see, the one that is done, it goes here again. One after making the this worker is making the glue, the other worker is actually gonna just look over the machine and the gantry. So making the glue is done. Again, working on the remaining products in that were processed and cured the night before. So this happens, and well, the sequence of the jobs that are happening they're not completely random right now, but they have a prefer to do the new modules first, but sometimes during their walk, they actually kind of like hand something on their way here, and then pick up some new products here. So as you can see, after just handing whatever it was here, they started picking up new products. So again, the second day we will not have anything doing in the room, in the second room, because well, we don't have any modules ready yet. So this sequence continues for the rest of the day, and well, let's jump to the next day. So we just increase the speed to 3000. Let it. Okay, this is 25 still, so we just go through, and as you can see, it jumps to 26 at 8 a.m. stops. So let's just reduce the speed. So now we have 18 proto modules in the system. We have 18 modules in the system, and we want to create 18 new proto modules. So well, the gantry still works the same, but the thing that changes is the OGP, because well, the module will be tested again before they will be picked up by someone from room 2. So if we run it, we see that well, yeah, and they will bring some of the products here. Then the priority is with the new product, so they will bring all modules not all proto modules. The modules, as you can see, the modules. Let me just pause it. As you can see here, the modules are they are 3-leveled, which shows that the base plate, sensor, and the PCB. Well, if you take a look at the modules here, these are the proto modules. Sorry, they have 2 levels, just the PCB and the sensor. So this is how you can actually just differentiate them and see which one is different. And for example, here these are just base plate. And if you hover over them, it actually shows that this is a base plate. Okay, let me just play it out a little, see how it goes. Again, they're bringing in the modules in the system. They're picking up from the output here, so bring it up. After the module is checked for quality by the working the OGP, we will see that the module will go somewhere here and wait for the so as you can see here, they are created, so the OGP checks the quality 2 at a time in a plate, but after they are checked for the quality, they will be separated to individuals. So 1 plate was checked, 2 modules will be created here. So after the 2 modules are created here, a worker from another room 2, which is, then the worker is the wire bonder, not the encapsulation. So the wire bonder will come here, pick it up. Let me see. Comes here, picks it up, and carries it all the way here to the wire bonding machine. So he mans the wire bonding machine. After it's done, he will just give it to this is the observation microscope desk. So as you can see, the encapsulation doesn't have anything to do right now because, well, he's waiting for products to come in. So we wait a few minutes, then after it starts, it goes to the OGP here, or the observation microscope, sorry, and it will check for the quality. And as you can see, well, this is the input line, so all products that needs to be checked wait here. If they are being checked, they will go under the microscope here, and if they are checked and done, they will wait here to be sent to the next station. So we will see that it will be done in a few minutes. Then it will, well, after it's done, it will be handed over to the input of the mini gantry here. Well, the thing with the mini gantry is we have a limit. So we say that, okay, it needs to reach a number of 4, 5, or whatever before the mini gantry starts working, because as you mentioned, the paste is getting viscose after like 60 minutes. So we just wait for a specific number to get there, and then start doing and processing all things. So right now you can see 2 numbers are already in. This is the total number that entered the gantry. This is the current number in the gantry, mini gantry, sorry. So you see that, well, there are still 2, and here you see that, well, 3 have been processed well, 4 right now, but this one is 4. This is the 4th one. The first one is being wire bonded, and as you can see again, this is the proto module empty, but after it is wire bonded, well, I just added like this antlers or what this legs to this module to show that, well, this is the wire bonded module, not a just simple module. Well, let us run. It will go. It's 3. Right now the setting here is 4, so it needs to at least get to 4 before it starts the mini gantry and makes a new batch of paste. So after well, this is the 4th one, so this will happen, well, really soon. So after quality check and passed, then it goes 4. When the 4 is well met, the worker will go here to this station. He is making paste right now. After making paste, he will just go there, attach the paste get the paste to the machine, and will just start manning. And as you can see, this is the amount of paste we have. So we consider that for each module we have, I just pause it, for each module here we consume 20 units of paste, and the paste created is, well, again based on the number of weighting. So it's 4, 80 is created. Right now 1 is here, so 60 is remaining. As everyone goes, okay, sorry. As every unit goes through this mini gantry, you will see that, well, this 60 will drop to 40, 20, and 0. This worker just going through this and getting new products. Well, now it's 3 weighting, including 1 in here, and, well, it's 40. So 2 is already processed. So this this cycle continues. This few things that happens is, well, this, as you can see here, this is the number that shows how many didn't pass the quality check for wire bonder. So as you see, there is a 5% chance that a product doesn't get and pass through the quality check or the observation microscope for the wire bonder. If the 5% happens, this product will come back to here and it will be 6. And for example, and the total number processed by this machine will be increased by 1. So the total number without anything should be 18. If there is a rework, 1, 2, or 3, it will be 20. It will be 19, 20, or 21. The same happens with the mini gantry. So let me just play it. So with the mini gantry, again, after it is done, it will be check for the quality. If the quality doesn't pass, again, it will go through and come back to the input of the mini gantry. So now what we have here is, you can see that the wire bonder is checking the quality in the observation microscope. We set the we will go through this and show how it is set, but, well, the observation microscope is a shared unit, so both can do. Wire bonder is just specific to wire bonder tech, encapsulation and making paste is encapsulation tech, but this station is shared between the two. So we'll show you how. But as you can see, well, after he is done here, well, he's checking the quality here. And if it passes, it will go. If it doesn't, this will be 2. But if it does, well, it did pass, and, well, it went to the next station. So as you can see, the worker is bringing everything from the output of the gantry to the input of the observation microscope again. So as for a brief moment, you saw that the encapsulation tech didn't have anything to do, because, well, the wire bonder tech was actually finishing the thing that it started, and there wasn't anything else to do. There was two wire bonded modules waiting on the gantry, but again, we are waiting for it to reach the number 4. After he is done, he will continue on working his products and bringing everything from the other room. He will and this encapsulation tech will pick up where he left off on the observation microscope. So this so let's see, this continues, and it's as you can see, you can always check the time here. It's 10:15 a.m. So sorry, 10:05, 10:06, and it just goes. So we just gonna increase the speed. Well, after he is done with checking the quality, the products that were the output of the mini gantry, which means that they were encapsulated and they pass the quality, they will go to the heating chambers here. Well, and they will be handed over to the heating chambers, and, well, the other products will go to the input of the mini gantry. Again, a new product came in, he is processing. It will be the 4th one, and after this one, so it will be the 4th one, again making the paste and working on the station. So I'll just increase the speed. Let's go. So it's the same sequence of product starts. If this worker is busy, someone else will pick up the leftover and just goes to the OGP, goes to the observation microscope and finishes what he started. and you can see a total of 8 products have exited the mini gantry right now. So this number should be 18 at least, because if there's a rework, it would be 19. But right now it's 18. So this is 9, 1 waiting, and 8 entered. So again, this continues. Okay, let's until it reaches 12 o'clock, which is off shift, and everyone will be go kind of like wait somewhere else. They finish up whatever they have started. So see, it's 12, but this one is working because he started working on a product. After he finishes, he goes to this. This is the kind of like, and you saw for a brief moment that something passed. These are the objects that are just done their time in the heating chambers. They're just go to this one. They didn't handle by workers. It can be simply added by that, but well, it wasn't in the document, so I just left it out. He will continue working on the rest of this modules and finish up with his work. Then okay, so as you can see, now we have 2 reworks here. So the total number, well, 3 reworks. It's a lot considering 18, but it's just chances, 5%. So the total numbers here should be 21, meaning that, well, 18 products were wire bonding and 3 were rewire bonded, so it will be 21. After 21, this worker will be done. He will just goes over other microscopes and he is done with everything, because, well, the other parts are not shared between the workers. So this worker is done for the day. He wire bonded everything, and the queue or the line for this one was done before now the new batches of the gantry come out. Well, I just added a breakpoint here, so I did explain the breakpoint as well in a few minutes. So okay, look, well, you see here that we have 3 remaining, but the workers the encapsulation tech will go over and create batch. This is the last batch of the day. So then for the last batch of the day, even if it's 2 or if it's 1, he will make paste, mix paste, and just work them out and just finishes that. Although they don't meet the requirement because they are the last few in the day. They will be, well, all will be processed. So it's 325. They have only 5. So, and as you can see, because we have 1 rework here, the total number will be 19 rather than 18, because, well, 18 products were encapsulated. 1 was re-encapsulated because of the quality of the product, and, well, because that module didn't pass the quality check. So again, working everything. Well, I will go through the breakpoint and what it is. So we will do the remainings here, and, well, done. So it's 420 something, and, well, 18 products were done, produced. So this is the whole system in the, well, this is the whole manufacturing system in line. The same thing happens every day. So the next day, again, the same sequence and same products happen. So these labels help us keep control of what's happening in the system, how many entered, how many are in each station, and stuff like that. So this one here, 12 already exited. We are still waiting for another, like, 6. It should be like 2 exited, another, because we have heated chambers is for 2 hours. So this should be 18 at the end of the day. 18 entered, 18 will exit. If there's a rework or whatever, they will increase the capacity, they will increase the workload on the station, but, well, they are not a new product. So again, 18 will exit. So if we wait, well 18, and well now everything is done. So so this is the whole system, and everything can be manipulated, and different layouts can be incorporated. But well, this is the layout that we have right now. So let me go through the bit of details in the next video.